So what I'm going to do is I'm going to help work out these first two problems to kind of get you started, and then I'm going to kind of give you some hints to kind of help you along with the rest of them. I'm not going to give you all of these, and we'll go from there. So let's look at this very first problem here. Actually, let's look at it both problems at the same time. It's first off asking for the width of the river, which is the distance from A to B from all the way over here from these 2 points. It's asking for these two pieces right here. But then it's also asking for the height difference between it. And if it's kind of hard for you to see because this is a two-dimensional picture, but you need to understand that the south side of the river, that shore is lower than the north side of the river. So there's a small height difference here. So what you actually have is a three-dimensional picture right here. Now, with that being said, let's talk about what it looks like if you were a bird flying over it. This is what the river would look like. Sorry for my bad handwriting on the computer. So this is what we know from a bird's eye view. We know that this distance from the south to the north is x. We know from this distance here to here is 25. We know that this angle right here happens to be 71.5. Now, this is what we've got to do. We need to figure out for x. So we're going to look at this angle and we're going to try to figure out which one of our trig functions will help us solve for x. So if we're standing right here at this angle, we know a couple of things. That 25 is adjacent to angle 71.5, and we know that x happens to be opposite of the 71.5 because notice here's my angle and directly opposite this angle is x, and what's directly adjacent to it is 25. So I'm looking for a trig function that's dealing with opposites and adjacents. And if we look at the very first three here, notice this: tan of theta, tan of whatever degree, is equal to opposite over adjacent. So we can use that equation. So that means that we're going to use tan of theta is equal to the opposite over the adjacent. So let's plug in our numbers. So when we put our numbers in, we get tan of 71.5 degrees is equal to x over 25. And what we want to do now is multiply each side by 25. And when we do, we get that 25 times tan of 71.5 is equal to x. Now it's just a matter of just simply plugging things in your calculator. So let's do that now. I'm going to say 25 times the tan of 75.1. And please excuse me if you're trying to follow along with my calculator. My calculator may be different than yours, so just use your calculator like you normally would. I have to plug in numbers in a little bit different for mine. Anyway, once I plug that in my calculator, I find out that x is equal to 74.7. And what we can do is round that to the nearest foot according to our problem. And this is what, and we actually will get that x is 75 feet. Now, we just found out that this distance between here and here is 75 feet. But there's another part to it, which is 2, and it's asking the height difference. And so what does this mean? Well, let me show you what it would look like if you were actually on a boat in this river. If you were actually on a boat in the river, you would look at something like this. You would happen to notice that the south shore is a little bit lower than the north shore. And that's what I'm trying to get you to see in this little lab is how do we find the height difference? Well, first off, we need to know this. We already just found out the distance between the two shores happens to be 75 feet. That was x. We've already found that out. And now our job is to try, to find this height difference right here. Okay? So what else do we know? Well, if you look at the paper, it says that the angle of elevation between A and B, this angle right here, this is what we call the angle of elevation. This was point A, this was point B. That angle of elevation is 1.5. So knowing this, we can actually go and try to figure out what this distance here is, which we're going to call y. Okay? So, what things do I know? Well, I know that this angle is 1.5 degrees. I know that it's the two sides that I'm looking at. One is y. Well, it's directly opposite of this angle. And I also know that 75 happens to be the adjacent angle, adjacent side. Well, again, we need to look at our trig functions. Since I know that I'm dealing with my opposite and an adjacent, which one of these three works with it? Well, it happens to be tan again, so because that's opposite and adjacent. Notice how these have hypotenuse. Well, I don't know the hypotenuse. Only things I do happen to have, I'm using right now, are opposite and adjacent. So that means I'm going to use tan of theta is equal to opposite over adjacent. And I'm going to go ahead and plug those numbers in right now. When I plug it in, I get tan of 1.5 degrees is equal to x over 75. My job now is to multiply by 75 on both sides, and I get that 75 times tan of 1.5 degrees is equal to x. So now that I've got that, it's just a matter of plugging that into my calculator, and I'll do that right now. And I find out that x is equal to 1.9639 blah, blah, blah. Well, according to the problem, it tells me to round to the nearest foot, so that's about 2 feet, okay? So, whoops, not x, that's a y. Yoink. There we go. I just realized that these should be y's. Sorry about that. So, what did we just discover? One, we've discovered that the distance between the south and north side shores happens to be 75 feet. We also discovered that the distance, the height difference between the two shores is 2 feet. Upon these two pieces of information, everything else is being built upon. So I'm going to clear up this little mess and let's kind of look at the next set of numbers. All right, so after finding that little bit of information, I'm going to not solve the rest of these problems, but I'm going to kind of guide you into the right direction, because once hopefully you kind of see what I'm asking for, it's basically rinse and repeat. You're looking at triangles, you're trying to figure out which one of these equations will you use and how to go about doing it. So this very first question, or the very next question that we have here, is asking for the distance of ND, all right? So we have ND. So what I'm going to do is I'm going to draw this over here to the side real fast. We have just a basic shape here, and a couple things that we know according to this north side is, if you look at the picture, it says that it's 30 feet here, 3 feet here, and 5 feet here. So this total distance from top to bottom is actually 38. Okay, it's 38. The other thing that we know is that their angle of depression on A, from which is right here, happens to be 45 degrees. All right? So our job now is to find out what D is. Well, there's a couple of ways that we can do that. So we're going to look at just this 45. So let's compare this 45, and we're going to compare these sides here, and let's put that 90 there. I know that this is my opposite, and I know that this angle right here, this side right here, which is ND, is my adjacent. So I'm going to look for which one of these three equations deals with opposites and adjacents, and guess what? It happens to be tan. So we have tan of theta, which is 45, is equal to, this thing is clicking, is equal to my opposite over my adjacent. So opposite over adjacent is going to be 38 over x. All right, so now our job is to solve for this. So let's try to get this figured out here. Notice this time, last time the x was on top, but this time the x or nd is on bottom. So we're actually going to be multiplying by x, and when we do, we get this: x is equal, or excuse me, x. When we do, we get x is times tan of 45 equals 38, but we still need to get x by itself. So now we're going to divide by tan of 45, and we ultimately get that x is going to be equal to 38 divided by tan of 45. Now that we know that, it's just a matter of plugging it into your calculator. I'm not going to do that with you. I'm going to let you do that on your own. So not only do we need to find ND, we're also asked to find NC. Well, this time, what do we know? Well, we know that this is the opposite, that 38 is the opposite, and we know NC happens to be our hypotenuse. So which one of these will work? Well, it's going to be this one. Sine of theta is opposite over hypotenuse. And so what we do is we're going to set it up just like that. This time it's going to say sine of 45 is equal to 38 divided by the hypotenuse, which in this case will be NC. And you're going to kind of do the same thing like you did on top. Again, I'm not going to work all this out for you. This is just to kind of guide you along. It gives you a start. All right. Now, let's look at the next one. It's asking for SD and SC on the south pillar. Well, here's the thing. I'm not going to give you all the hints on this one, but I am going to start you with this. Notice this. This one is 30, this is 3, this is 5, and then there's a y here. Well, what's y? Hey, that's what we found in question number 2. It's that 2-foot difference. So this particular pillar, instead of being 38 feet tall, is actually going to be 40 foot tall. And your job is to find SD and your SC. And you're going to do it just the same exact way as we did these two over here. You're going to look at it. You're going to find your angle of depression. Well, what is it? It's 45. So it's literally just the same setup as the first set of problems, but instead of using the number 38, you're now using the number 40. Okay? So that's how you're going to do these. All right? And that's about as big as a hint as I'm going to give you. Now, let's take a look at the next set of questions. All right, so this first set of questions is we're trying to figure out the actual distance of the bridge. We know how wide the river is. We found that out in the very first question to be 75 feet. And we know the distance between the edge of the shore and this pillar happens to be 12.5 feet. And we know the same measurement is on the other side. So if you know that this is 12.5, this is 75, and this is 12.5, what's the total distance? I'm going to let you figure that out. That right there, once you know what that number is, it's going to help you figure out these other ones. It's asking for how far is the distance between the towers of cable A connects. So if you know that whatever this entire distance is, and according to your instructions, this is a quarter of the way, well, figure out what a quarter of the entire bridge is. And then it's going to ask you what the distance is between here and where this cable connects. And that is half the way. So if you know the entire distance of the bridge, you can figure out half the way. Okay? These are the hints. Again, I'm not giving you everything. I want you to try to figure some of this stuff out on your own. Now that you've got those measurements, you should be able to find your other things. So you should be able to find this distance here. What would you know? You would know what this distance is. You already know what this distance is because it's a quarter of the way. And you know the distance of the tower is 30 feet because I've mentioned it to you. So you have this distance, you have 30 feet, and since you know those two measurements, you can find out what A is by using these proper trig functions. Okay? Again, it's kind of setting up the same way. I'm not purposely not giving you too much information right now because I want to see what you can do on your own. And you're going to do the same thing with all of them. All right. So let's scroll down a little bit more. All right. And again, it's the same concept that we're having here. We're still using the trig function. So if we look at this, we know that this measurement from here to here happens to be 8 feet. We also know that this measurement here is 14 degrees. And since I know what these two measurements are, I can use my trig functions, the proper trig functions, to find this measurement of ns, and I can find this measurement of nr. And if we look at this side, I have 3, 5, and y. Well, don't forget that y happens to be 2 feet. So I know that this height right here is 10. Since I know that this is 10, I know that this is 14 degrees, I can figure out my two measurements again. And all of that is by going back to this and figuring out what sides are opposite and what sides are okay. He's in his room. Okay.
Is he asleep?
No, he's watching his Bob. So what we know is that all of these are based upon these three trig functions. Hopefully this will help you, and just do the best you can. And since this is getting kind of late in the summer, don't be too harsh on yourself about this. Try to get this on back to me as soon as you possibly can, okay? And you'll be all right. All right. Talk to you later.